All right, so looking at this in context, okay, this is the page that we're on. It should say at the top, it's like, should be the very last page, I think, but it says projectile motion, okay? So this is where we're gonna be at today. All right. For projectile motion, okay, we're gonna mess around with the calculator a little bit today as well. You need to get some headphones out, you need to get some paper, you need to be with us. Take your hat off too. All right. So we got number one, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. Okay. It gives you the equation for how this looks. It tells you the equation is h is equal to negative 16t squared plus 90t, okay? Telling you h is the height, t is the time, okay? But it gives you your equation, okay? So what do you think you should do with the equation? Plug it in your calculator, okay? So go to y equals, okay? And then we'll plug that in. So we got, what is h is equal to the same as? Y is equal to, okay? So we don't have to do anything there. Okay, and then what is t the same as? X, okay? So what we're gonna end up with, is negative 16 x squared, okay, plus 90x, okay? So negative 16x squared plus 90x. Which term is this missing? Your A term, your B term, or your C term? Your C, right? It doesn't have a constant, okay? Does that matter? No, not necessarily, but it is not there, okay? So you want to notice that. All right, so when you go look at the graph, okay, number one, this is a crazy looking graph, right? Because we can't see the vertex being where we have our turning point. Remember, that was one of the things we talked about in the key features part, was your vertex. Okay, you got a minus sign. All right, so one of the things that we can do to kind of look at our whole graph, okay, and I talked to, I know a couple of y'all yesterday about it. Okay, notice right here where my mouse is, and I just clicked it red. Okay, you got the zoom button up top. Okay, you got different options. You can zoom in, you can zoom out, and then Z standard means going back to normal. Okay, those are really the only three at this point that you need to know. In, out, standard. Okay, well, if we can't see all the graph, which one do I need to press? Zoom out. So zoom, you press zoom, and then you press 3. Or scroll down and press 3. Okay, and then just press enter. Okay, and you can zoom out however far. Okay, now for y'all, I had to click it twice. I don't know how many times y'all had to click it, okay, to where you can see the whole thing. Okay, but it kind of makes it a little bit difficult because now it's real narrow. Okay, but I still need to know for number one, A. Okay, it tells me to find the maximum height of the ball. Okay, so when I look at my graph, where would my maximum be? Right here, yes? Right, that's as high as the ball is ever going to get. So we got to figure out what is that value. Okay, so one thing that you can do, okay, for your value, if you need to find that, you can go to trace, just press trace. That's all you got to do. Not second trace, nothing, just press trace. All right, and notice you got this cursor, right? And you're going to follow that cursor until you get to the very top. Okay, you get to the very top there. Everybody with me? Is anybody paying attention? Yes? All right, so when you're at the very top, this is what you've got, okay? And you've got a roundabout number here. Okay, you got a roundabout number. It's not going to be exact for what we're looking for, but it kind of tells you what to get close to. Okay, so for our maximum height, this is the same thing as our vertex. Okay, so you could change this max to say vertex. Okay, so you got to change that to say vertex. And what would our vertex be close to? What's this order pair here? Y'all got it on yours. It might be a little bit different, but that's going to be what it's close to. So that's what you got to put on A, right? When it talks about the maximum, we're trying to figure out what is the max height. Okay, is height represented by X or Y? gonna be your y, right? Because it's when it goes up, okay? So our height, find the maximum of the height of the ball, it's gonna be, y is, we'll use this symbol right here for approximately, because we don't know that it's exact. Okay, and we'll say, 115.7. Okay, so it gets almost to 115.7, and then here is feet. Okay. Any questions on how I found that height? All right. So part B asks, how many seconds will it take the ball to reach the ground? Okay, so think about what represents the ground. Okay, if y has to do with height, and this, we're saying it gets all the way to 115 feet, what does the feet have to be? What does your y have to be to represent the ground? All right, so think with me here, okay? Huh? Okay, not quite. All right, I'll take this right here. All right, how tall do we think the ceiling is? Anybody, just a guess. What do we think this is? Well, it's not 7 foot, surely. It's like what Coach actually said, it's 10, 12 feet here.
Yeah.
All right, so we say that, we'll just call this 12 feet. Okay, just like this soccer ball problem, right? We've got an upward velocity. Okay, so that would mean that I throw this upwards, right? Everybody's with me? Okay, now I take this and I find the vertex. So just like we found here, we found the max height. So say I throw it, we found the max height, which was 12 feet. Okay, so for me to hit the ground, so up here was 12 feet, right, when I was at my vertex. Okay, for B, how many seconds will it take to reach the ground? What is the height of the ground? What does it have to be for it to hit the ground? 0. Okay, so when y is equal to 0, okay, so that's what we're going to be looking for. So let's go back to Zoom. Let's go back to Zoom and then press 6. So we can see the standard there. Okay, well when y is 0, like what we have here, what is this axis called? What is this axis called? Is this your x or y axis? X. Okay, now when we found all this unit, okay, when we've talked about solving, we've been trying to find x-intercepts, right? And we've done that by our second trace. So I'm going to press second, trace, 2. Okay, now, am I looking for where it crosses here or here? Think about what the problem says. How many seconds will it take for the ball to reach the ground? When I'm here, has the ball been thrown yet? No. Okay, then it's thrown up, right? Okay, and then it's going to touch the ground here, right? Everybody's with me. So this would be the time that we're looking for. How long does it take for the ball to hit the ground? Okay, so we're going to use our second trace 0 and go over to that and find that x-intercept. Okay, so click through until you see it. It might be quick when you get over there. Let's see, there it is. All right. So I need my left part of that x-intercept. I press enter. Then I need the right part of that x-intercept. Press enter. Okay, then you're going to press guess, and you're going to find that 0. So how many seconds did it take it to reach the ground? You started to say it. What we got?
6.
Okay, well about 6, but we had 5.625 seconds. Okay, 5.625 seconds. So it's saying that we threw this up, it took it 5.625 seconds to hit the ground here. All right, any questions? All right. So here, let me talk about this. This is not part of the problem, but here that point was 0, 0, right? That's where we started. So time was 0, we hadn't thrown it yet, and height was 0. I should have thrown that away. Okay, but that's me saying that this ball is right here on the ground at 0 seconds, right? Okay, now we kicked it, the ball went up. Okay, it stayed in the air for 5 seconds. 1, 2, 3, 4, 5. Then it hit the ground over here, right? Y'all see what I'm doing? Okay. What happens if I started at time is equal to 0, but I started the ball right here? Would I be at 0, 0? No, right, because I'm higher than the ground at 0, right? So the way you would see that represented was that you would start higher on the y-axis. Okay, we'll see that I think on this next problem, but I wanted to bring it up before we saw it. Okay, so let's look at number 2. We've got an apple launched directly upward for 64 feet per second, okay, from an 80-foot tall platform. Okay, that's what I'm talking about. It wasn't shot from the ground, was it? Yes or no? No. It was shot from a platform that was how tall? 80 feet. Okay, so we'll see how that looks on our problem here. Alright, so let's go to y equals. Alright, and let's put in our function. So we got, it's actually, I shouldn't have probably cleared that out. That was, no, it's different. Never mind. Alright, so negative 16 x squared. Okay, plus 64t. So plus 64x, right? And then plus 8. Now, y'all might actually get to see this a little bit better than what I have on my screen, just because it's going to be smaller on mine than probably yours. Okay, but let's look at, actually this might be a good problem. I don't know, if this doesn't look good, then I'm going to go to Desmos and show you. Okay, so let's go to our, should hit second, all right, let's see, table. Okay, so yours should look something like this. Okay, now, can we see where it started at? No, right? You would think maybe that this would be part of it, but why would this not be part of it? This point right here represents 0 seconds. Okay, so when I'm over here, that would be negative seconds, right? Could I have started something 2 seconds ago if I thought about it now? No. Okay, so that's why this is not a part of your function. Okay, now we can't see where it started. Okay, so I need to zoom out. So zoom 3. Okay, that, like I said, it might be difficult. See, look how tight that's going to be. It's just like that last problem. Let me, Y'all, you got to press enter when you do it. So zoom out and then press enter. Let me see if I can see it better on this one. Yeah, you might have. I had to zoom twice. Did y'all have to zoom twice to see it? Yes, no. Nobody's doing anything. Everybody just wants to stare. All right, what do we have? What was my problem here? It was what? Negative 16. That should be y equals negative 16x squared. What was after 16x squared? Plus 64x plus 80. All right, so let's look at it on Desmos. Let's move this over. All right, and let's zoom out on Desmos. All right, so looking at this, okay, on Desmos, we can see that, and it's kind of hard to see. Maybe I can zoom in here and we'll see. It's not the best way to do it, but let's see. All right, notice at this point at 80, that's where you're stopping, right? It's exactly on the y-axis, or starting, I meant to say. Okay, so this is where you're throwing that apple up, okay? And the apple travels up, 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 continues to go up, all the way till you get right here, okay? Y'all see this? This would be the what? What's the word for this point right here? Okay, it would be a max, but what's another word? Vertex, right? That's what we wrote in place for over there earlier. Okay, so find the maximum height of the apple. Here's one thing that Desmos can do for you, okay? And you have Desmos on the test as well, okay? But with Desmos, I can click this point, okay? I can click the point at the top of my graph, okay? And it tells me that this ordered pair is at 2, 144. Okay, so which one of these represents the height? 2 or 144?
144.
144, because that's your y. Okay, so the maximum height is 144. What does the 2 represent? Time. So if time here is 2, how many seconds have passed? 2 seconds. Okay. So looking back at the problem here, okay, find the maximum height of the apple. Okay, what height did we get to? What did I just point out up there? 144 feet. So this is 144 feet. Okay, so then what we have to find out is how long did it take the apple to reach the ground? So the apple reaches the ground at what height?
144.
Now that's the max height, okay? What does the height of the apple have to be to reach the ground? 0, okay? So we're gonna go from our 144 here, and we're gonna start going back down. Okay, we're gonna start going back down until we see that it touches 0. 5 seconds, is that what it is? Let me get down there a second. Alright, yeah, that's what we got, 5 seconds, right? And y'all did, with that, y'all did your second trace too, right? Yes? Yeah. Alright, or you could have used Desmos. Desmos right here, you could have looked at Desmos and you could have clicked this point right there. Okay, and had 5 seconds. Okay, so your time here, how many seconds will it take the apple to reach the ground? 5 seconds. Alright, any questions on 1 or 2? Those are similar problems. Alright, let's look at 3. Let's see. 3 is basically the same problem, so I don't want to look at 3. See if we got another one. Let's see. So here's one, okay. Eva is jumping on a trampoline. Her height and time can be modeled by this equation. Okay, would Eva reach a height of 14 feet? This is number 7. Okay, so y'all tell me what this equation is when I get over here to Desmos. Look at number 7. I know it's negative 16t something, or 16x. Okay, what's after that? Plus 20x. Plus what? Plus 6. Okay, so we're trying to figure out, what was the question? We're trying to figure out, will Eva reach a height of 14 feet? What do you think? Yes or no? Looking at this graph right here. Let me zoom in. Okay, does Eva reach a height of 14 feet? No, right? What is her max height? Her max height is 12.25. 14 is all the way up here. And does she ever reach that? Yes or no? No, right? So for number 7, right, would Eva reach a height of 14 feet? The answer is no, right? Alright, so that's some ways that you can see word problems. That's what Khan Academy will be on. I'm going to take just a second, go back to some of the stuff we did at the start, okay, just to show you. Okay, you can use Desmos. I recommend for your zeros, I mean, just because we've been doing it that way, I would still try to find your zeros here. Okay, but you can also find your zeros on Desmos as well, okay, by going over here and looking at where it crosses the x-axis. So 1.5, negative 2.5, or negative 0.25. That's an option as well as Desmos, okay, if you like Desmos. So let's look back at some of this other stuff. Oh, no, let me do this real quick. I promise you I'm not just trying to work you just because I want to. Alright, you've got the quadratic formula. So everybody go back to this page. It's a few pages back. Okay, it's a few pages back. Alright, you need to be able to, and I'm going to do this example with you. Okay, let me zoom out just a hair. Alright, so look at the example. We didn't do this example yesterday, did we? We just started with number 1. Alright, so look at this example. Okay, you've got the quadratic formula here. Okay, a type of question that you might see on the state test would be to make sure that you can plug into the quadratic formula. So for you to be able to do that, you have to be able to know what A, B, and C is. Okay, well remember, we keep talking about standard form of a quadratic equation being ax squared plus bx plus c, right? Is equal to 0. Okay, we keep talking about that being standard form. Okay, so for us, we've got to be able to make sure that the equation is in standard form. Okay, we'll check. This is ax squared minus bx minus c is equal to 0. That's fine, right? We've got the a, b, c in that order. Okay, so we're good to go. Okay, then we need to say, well, what is a? What is b? What is c? Okay, a and b are coefficients. Somebody remind me what a coefficient is. The number in front of a variable. Promise you will see that on the test. I won't promise you because I haven't looked at it yet. But just about every test that you've taken this year, there's been a question about coefficient, right? Okay, a coefficient is a number in front of a variable. Okay, a constant is what? A number by itself. Okay, some people call it a naked number. Okay, a number without a variable. It would be something like what you have here with negative 36. Negative 36 is a constant because there's no variable. It's naked. Okay. And then the variable obviously is your letter in the problem. Okay, we should know that. Okay. And then that 2 up here is your degree or exponent. But degree is probably how you'll see it on this test. Okay. All right. So we need to identify what is a. Okay. Well, we've got ax squared. So a is the number in front of x squared. What is a for this problem up here? 1. Right? There's no number there. So there's an understood 1. All right. What is b for our problem? Be careful. Be careful. What we got? Negative 5. B is negative 5. Okay. What is c? Negative 36. All right. So what we have to do with our quadratic formula, and we don't really have much room. Okay, but you're saying x is equal to the opposite of b, right? It says negative b. Okay, what is the opposite of b? Positive 5. So you got positive 5 plus or minus, okay, the square root of b squared. What is b? Negative 5. So negative 5 squared minus 4. That's always a part of it. Okay. Times a. What is a? A is 1. What is c? Negative 36. All that's under a square root. Okay, and it's over 2 times a. Okay, so 2 times what? 1. Okay, now you've plugged in for the quadratic formula. Okay, that might be all that's asked of you. Okay, the Khan Academy that I assigned yesterday that I ended up deleting, okay, really wanted it kind of simplified a little bit, and it would have taken it to this. X is equal to 5 plus or minus the square root of, okay, we know 5 squared is 25. 25, and then somebody do negative 4. Okay, you got negative 4 times 1, which is still negative 4. So negative 4 times negative 36. What you got? Negative 4 times negative 36. Somebody just plug it in the calculator. 144 plus 144. Okay, over 2 times 1. Okay, well 2 times 1 is just 2. Alright, so what is 25 plus 144? 169. Okay, over 2. Okay, that might be as far as it takes it there. Okay, it might be as far as it takes it there. We know the square root of 169, and I'm not trying to lose people by finishing this problem because it can be difficult. Okay, but I'm just going to continue to work this that way we at least see it. All right, we've got x is equal to 5 plus or minus. Okay, the square root of 169 is what? Somebody just type in. Okay, second x squared 169. So the square root of 169. 13. Okay, and this is over 2. Alright, so what the quadratic formula does, this plus or minus, now we can find our solution, or our x-intercepts. Okay, I would still want you to work this on the calculator, but let's just show it. Okay, we got x is equal to, it can either be 5 plus 13, 5 plus 13 is what? 18. 18 divided by 2 is 9. Okay, that can be one of my solutions. Okay, what is 5 minus 13? Just type it in. 5 minus 13. Negative 8. Negative 8 divided by 2 is negative 4. So that's where you would have crossed the x-axis. That's how the quadratic formula works. Okay, if you worked it by quadratic formula, that's how you would do it. Okay. But what I'm worried about for the quadratic formula is that you can take A, B, and C and plug it in. You know how to take, I know what A is, I know what B is, I know what C is, I can plug this in. Okay, let me show you what you're going to be given on the state test. And I'll probably just put this up on the board yesterday, I think, or I'll put it on the board yesterday, put it on the board tomorrow. Let me see. I think this is Algebra 1, huh? Let's see, reference sheet, okay? What you're gonna be given on the state test, one of these formulas, let me clear this off the board. Okay, one of these formulas on this sheet that you're gonna be given on the state test is your quadratic formula. Okay, so do you need to memorize that formula?
Yeah.
Why would you need to memorize it if it's right there?
I mean, it's good to know.
Huh?
It's good.
Well, yeah, I mean, yeah, it'd be good to know, but you don't have to memorize this because this sheet is given to you on the state test. Okay, this formula is there. Okay, so all you got to be able to do is say what is A, what is B, what is C, and then let me plug into it. Okay. All right, that's quadratic formula. Let's see. We've worked on solving the last couple of days, so I'm not worried about that. Remember axis of symmetry. Okay, axis of symmetry is x is equal to the opposite of b over 2a. Okay, think about it this way. Okay, your quadratic formula there is very similar to your axis of symmetry formula because this part right here is your axis of symmetry formula, right? X is equal to the opposite of b over 2a. That's where that comes from. Okay, so you can use your axis of symmetry formula to find the vertex, also your axis of symmetry. Let's look at number 6. All right, so what is my b value on number 6 here?
Negative 24.
Negative 24. So what's the opposite of that? Positive 24. Okay, times 2, or so over 2 times a. What is my a value for this formula? Negative 3. So 2 times negative 3. So you've got 24 over negative 6. Somebody type that in. 24 divided by negative 6. Negative 4. So x is equal to negative 4 for my axis of symmetry. You'll probably see that on the test. Okay, remember the axis of symmetry also tells you the x value of your, somebody, help me out here, Jalen, I know you know this. Axis of symmetry is the x value of your, the axis of symmetry is the x value of your vertex. And I didn't have to underline that, did I? Everybody knew it? Yes? Y'all say yes to make me feel better. Alright? Alright. So that's your axis of symmetry. Okay? That's your x value of your vertex. Okay, that's how you can find your vertex if you need to find it that way. Alright, let me clear this. Let's go back, check anything else that we might need to. Let's see. Standard form. Somebody tell me what standard form is. Come on, guys. We've talked about this already, like the last 5 minutes. But talked about it enough. What is standard form of quadratic equation?
Y equals ax squared
Okay, so we got ax squared
plus bx
plus bx plus c. Right? That's your standard form. Okay? Y'all should know this. For sure. sure, okay? Let's see. Okay, factoring, let's review this real quick. Coach Jackson showed you how to do this. I'm sure he did a great job. Let me work one with you just in case, okay? So factoring, y'all should be on this page with me. So on the second page of factoring trinomials, okay, we'll look at number 3. Okay, so everybody scroll with me here, or flip pages. Okay, meet me on number 3.
Is that the same page we did that day?
Yeah. Yeah.
Let's see, this one.
Okay, y'all might have even worked this one. If y'all work this one, I can do a different one.
Did we work on it together? It's worse than it did.
You got a staple remover?
Yep. Did y'all work this problem?
Pamela ain't even on that page, Coach.
That's because Helen just wants to stare. They don't want to learn.
I can't even follow with that one, not.
Should be.
Number 1?
We worked that one? You good?
Alright, so y'all work that one. Let's look at number 2 then. Okay, so number 2 on that page. Okay, so number 2 here. Is there a greatest common factor between 8, 10, and 3? Is there a number that goes into 8, 10, and 3? No, right? So that's why we're gonna have to do it this method, okay? So since there's not a number that goes into 8, 10, and 3, I'm taking my A value, Ms. Springer, and I'm multiplying it to my C value. Okay, y'all remember this? Okay, you've got y squared minus 10y is so here we're gonna have 8 times negative 3. What is 8 times negative 3? Negative 25. Dietrich can't be the only one that knows how to type that in the calculator, surely.
My calculator understood.
Well, then grab a different one. Don't sit there and be helpful. Minus 24. Okay, now we're looking at what are these factors, Trinity, write this down. What are these factors of 24? What numbers multiply to be 24? Okay, 1 times 24 is equal to 24.
3.
Okay, we know 3 is, but there's 2. 2 times what? Gives you 24. 12. Okay, 3 times. Y'all, all you have to do is say 24 divided by 3. What is 24 divided by 3? 8. 4 and what? So 24 divided by 4. 6. Okay, so this is one that B is negative, C is negative. So that tells me for my problem that my larger factor has to be negative. So negative, 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 negative. Now, which one of these is going to give me negative 10? Is 1 minus 24 negative 10? No. Is 2 minus 12 negative 10? Yes, I see shaking heads. Okay, so we've got y plus 2, y minus 12 as my factors. Okay, but what did I do from the front? What did I have to do from the front? I multiplied. So how do I keep it even? I now have to divide. Okay, so I'm going to have to divide by that 8. Okay, so this is simplified, right? This becomes y plus 1/4. Okay, this becomes y minus 3/2. Okay, remember if you have a fraction, you're taking your denominator and multiplying it to be the coefficient. Okay, so this will become 4y plus 1 times 2y minus 3. Okay, for this problem. Okay, that's if A does not equal 1. What was A on number 2? What was my A value for number 2? 8. Alright, let's look at something different. I figure it's probably better for a review, okay, because you're going to have time with us having 2 days for the test, you'll have time to get these assignments done, probably after you finish the test, or that second day, okay? Test is tomorrow, for this unit, yeah. Huh? Test is still tomorrow, whether you here or not. Alright, let's see, factoring, we did a lot of those, we'll probably skip that. Difference of squares, remember you're taking the square roots of those. The other major thing that I wanna look at, okay, multiplying binomials, we did a lot of that. Remember that's you're using what method? You gotta multiply, you're using your box method, right? So you got something like this, you've got 6a times 2, so you would create your box. Okay, you got 6a, 2a plus 3. And that's number 8 that I'm working here. Okay, I'm multiplying on the multiplying binomials page. Alright, what is 6a times 2a? 12. 8 times a is? A times a is what? A squared. So you got 12a squared. Okay, 6 times 3, or 6a times 3. So what is the 6 times 3 part of that? Type it in. 6 times 3, 18. Okay, and then a, right? A times 1 there. Alright, 2 times 2a. 2 times 2 is? 4. And then that becomes 4a, right? 2 times 3 is? 6. Okay, so what you have right here are what? Like terms, right? So those can be combined. Okay, so we'll start off, remember we want this in standard form. Okay, so from degree greatest to least, so you're gonna have 12a squared. Okay, what is 4a plus 18a? 22a. Plus 22a. Okay, and then plus 6. That's multiplying binomials. Okay, if you had a binomial, so 2 terms times a trinomial, which is 3 terms, remember you would create a 2 by 3 box. Okay, if you have a monomial times a binomial, you would have a 1 by 2 box. It just depends on what's being multiplied, right? Y'all remember this? Okay, that will be on the test tomorrow. Use your box method, okay? Let's see, getting kind of close to where we started from at the start of the unit. Let's see, perimeter. Perimeter means to do what? Add. Area means to multiply. You have to know that. That will be on there. Either perimeter or area will be on there. Okay, perimeter is what? Y'all just said it. Add. Perimeter, add. Area, multiply. Okay. Adding and subtracting. Okay, remember with adding and subtracting, adding is nothing more than just adding like terms. Okay, subtracting, the difference with subtracting is you have to distribute that negative inside. Okay, so let's look at this one. 22 is a subtracting one. We've got 3m squared plus 7m. So I'm on the page, it says adding and subtracting polynomials. What? Alright, minus 1, so we've got, what number am I on? 22. Okay, so you got adding and subtracting polynomials, that's the page I'm on. Jaden, be with us please. Alright, then this becomes negative m squared minus 2m plus 5. Okay, now I'm looking for my like terms. Okay, my m squareds go together, my m's go together, and then my constants go together. Alright, what is 3m squared minus m squared? So 3 minus 1 is 2, so you got 2m squared. Okay, 7m minus 2m. 7 minus 2 is 5, so plus 5m. Okay, and then negative 1 plus 5. Basically the same thing as 5 minus 1, which is 4. Okay, you got to use your calculator. Got to use your calculator tomorrow. Okay, also another big thing, as a side note that I notice on people's tests is if I go look at how long you spend on a problem, some problems you spend 13 seconds, you just guess, right? You get about, on the state test, you get about 2.5 minutes per problem, okay? So when you take the test tomorrow, you need to think to yourself, I should spend about 2.5 minutes on this problem. Now, if you get it before 2.5 minutes, that's great, right? Because then that gives you time somewhere else. But if you're on a problem for 5 minutes, you've spent too long, right? So you gotta have that mental clock in your head on 2.5 minutes per problem. 2.5 minutes went by, I need to move on. Okay, I think y'all's test has the timer on it, right? It shows y'all on Edulastic, yes? I think so, I think it does too. Okay, so you can kind of look at that timer and tell where you're at. All right, some easy questions that you should get right. I think is this next part here. Some easier questions that you should get right on this is what it is. That you should get on the state test too, but definitely on tomorrow's test. Some easier questions that you should get is classifying your polynomials. So degree and number of terms is how you classify. Degree of 0 would be a constant number, like 4. 4 is a constant number. There's no exponent, right? There's no variable, there's no exponent, right, Braxton? Okay, so that would be an example of a constant number. Okay, a linear number would be something like 3x, right? That x has an exponent of what? 1, right? Y'all focus, please. We take a test tomorrow and y'all not focusing. Y'all just staring. Alright, a quadratic would look like something like 5x squared, where our exponent was 2.
Yeah, we do, but,
Okay, y'all focus, okay? The cubic would be something like x to the 3rd power. Y'all should write this down. This is good notes. Okay, and then the quartic would be something like 7x to the 4th power. Okay, all based off your exponent. Alright, the other parts are going to be your number of terms. A monomial could be something like 3x squared, right? That's only one term. It's only one term, so that's a monomial. Okay, the binomial would be something like 7x plus 2, right? That plus 2 is our second term. Okay, so that's a binomial. A trinomial would be something like our quadratics that we're used to. Okay, the x squared plus 7x plus 9. Okay, that could be an example of a trinomial. Then a polynomial is everything else. Okay, anything 4 or more terms. Okay, which I think. Alright, so that's also reviewing everything from this unit, okay, along with today's lesson. I'm going to post the 3 assignments on Khan Academy. So you'll have just a little bit of time in class to get those done. But the main time that you're going to get those done and get all the other ones done is going to be once you finish the test, okay? So you'll be able to focus on that. Okay, so grab your computer, head to Khan Academy.